An attractive phosphorus fertilizer includes, among other types of fertilizers, monoammonium phosphate. Monoammonium phosphate contains ammonium and an orthophosphate ion, as you can see in the top right-hand corner. This is a solid fertilizer. And it's interesting to note how this is made. It's made by reacting phosphoric acid with ammonia gas. So it's made by taking rock phosphate, reacting with sulfuric acid to form phosphoric acid, like we learned with triple superphosphate in the previous video. We take phosphoric acid and we combine it with ammonia gas from the Haber-Bosch process to form monoammonium phosphate. Interesting that the nitrogen fertilizer industry is intimately tied to the phosphorus fertilizer industry. So we could go on and on about the intimate ties between the fertilizer industry and likely the oil and gas industry and shipping industry, etc. It all ties together. So that's a puzzle in and of itself. For monoammonium phosphate, however, let's continue with this. So monoammonium phosphate has a relatively high analysis, 11,520, so 52% P2O5, and it also contains nitrogen in the form of ammonia. When we place this, we can place it with the seed. It typically has low ammonia volatilization potential because of point letter D, right? Point letter D tells us that when we place monoammonium phosphate in the soil, it can acidify the soil right around where the fertilizer prill or pellet goes. And it can be between, it says about pH 4, but it can be between 4 and 5, or even greater, depending on the buffering capacity of the soil. So first of all, how do we know that it has the likelihood of reducing pH right around the point of contact with the soil? We know that based on what you've learned previously in Unit 6, that this fertilizer contains H2PO4. And on this set of curves, which shows you pH on the x-axis versus the fraction of total orthophosphate on the y-axis, that the pink curve is H2PO4. And H2PO4 maxes out around between pH 4 and 5, okay? And so we can predict that local acidification will occur when you place this in a soil. The amount of acidification and the time of acidification is all based on the soil buffering capacity or resistant to change in pH, which you learned about in the soil acidity unit several units ago. So this is the puzzle. This is the soil fertility puzzle that you are learning throughout this semester. So one of the main reasons why there is low volatilization potential with this fertilizer is because of the local acidification. And you learned that the pH needs to be roughly above pH 7 for volatilization to be of concern, the puzzle. And if the pH in the localized zone of fertilizer placement is about 4 or 5, is volatilization going to be an issue? No, it's not going to be an issue with a monoammonium phosphate fertilizer application.